everyone. This is Roshini from HSBC. I am the principal data scientist in the global banking and markets data analytics team. I'm going to talk about machine learning in finance and how what the different steps that we take from data quality to production. I also represent women in machine learning and data science, as well as women tech makers, basically to promote diversity and to help more women participate in technology. So when we think about machine learning projects, we generally think about a lot of data scientists, and that's what we need to hire. But I just want to point out, when you want to build a scalable machine learning project, even if it's at a small scale at the beginning, it's important to have this bare minimum pipeline in mind. And that is to definitely include in your team data engineers and data scientists. I think both are increasingly important, especially actually data engineers might be a little more. The reason behind this is that a lot of the times your problem might actually be more from setting up the overall infrastructure, from making sure that the data is in a good place, and to also make sure about how the data is ingested, how the data is being constantly updated, and so on. The data scientists obviously come together with the data engineers and the business to identify this problem, translate those requirements to technical steps, and also understand what is the performance indicator. That means what is the definition of success. Moving on to EDA, you still want a lot of engagement from the data engineers, because while the EDA from the data scientists is extremely important to identifying what features can be used and what cannot, it's good for data engineers to, in parallel, start building what that would look like from a minimal pipeline. This is going to be constantly changing, but you can always have a skeleton build in the backend. From the feature engineering aspect, it's important to think about baseline models and what sort of features play a role in that. And then the data engineers would work collaboratively in the process to then make sure that those the skeleton again exists, as well as the code is optimized and it makes sense from a deployment aspect. Having that entire infrastructure already in place as you go and test more and more different models is so helpful, because it avoids those 1,000 notebooks that start being produced every time you build a new model. Instead, you already have an infrastructure where you can just exchange the model code, and then you just play it and it all runs smoothly. And then at the end of this process, you would then go towards model selection, making sure that there is reporting, testing behind it. You need both data scientists and data engineers to be there. Data scientists would definitely help more from the interpretation side, as well as making sure about your model, how often the model needs to be updated. Data engineers are the ones who will then design this in an extremely intelligent and robust way, as well as provide things like how can you make sure that you're monitoring the model performance and send out the alerts as and when necessary. So when we think about the different frameworks that you could use, if you have big data, then obviously you would want to go to something like Hadoop, or you go more from the cloud aspects. We have an on-prem because of regulatory and data sharing restrictions right now, but we are moving towards GCP as well. When you also use things like Apache Spark, they already have integrated machine learning libraries, so it's worth checking if you could do something from a distributed aspect as well. We also use a lot of different machine learning libraries like TensorFlow, sklearn, and as I mentioned, MLlib from Spark. Then when it comes to making sure that you want to take it to production, we use things like IntelliJ. And we have a lot of our data pipelines running through Scala because we feel that it works better with Spark. Then when it comes to sending that to production, it's good to have something like a Jenkins build with deployment tests in place, so that you're always sure that whatever you're sending out has not impacted what used to run before. Always make sure that there is good amount of integration tests and everything is version controlled. It would really save a lot of time. We use things like Airflow to then schedule those runs, so that when one dependency is over, it automatically fires the next one. This then helps things to run automatically without a lot of human intervention. Think about visualization, because at the end of the day, you want to be able to get your graphs and those things already built, so that you don't rush to do that when you need to present this to your stakeholders. When you want to go bigger in terms of your pipeline, you want to build something that's more global, that suddenly includes a lot more data sources, then you need to bring in people like data analysts, you want to bring in data architects, you want to have a project manager to make sure that everything goes smoothly, especially engagement with stakeholders is something so important. When it comes to having that constant feedback mechanism, you want to include your stakeholders, your end users as in part of the process so that you identify the things that are useful to them at the start and not at the end. It's super important for bringing everyone and part of this process from the beginning to the end together and constantly talking to each other, because that's how we would achieve collaborative gains. This is how we identify things that don't work at the beginning rather than at the end, and then that increases the time to delivery. Sometimes it can even cause for things like budget to go over, and then your project just never reaches production. So very important to make sure that everyone's there so that the right questions can be asked, the system can be more robust, there is a knowledge transfer process happening, and you also have your design considerations constantly being updated and being catered to the one who's going to use them. So let's talk about what that blueprint looks like. I've identified this as 10 imperative must-haves, but obviously it's way more complicated than that, and there's loads of things to consider, but definitely make sure to tick off these 10. Let's think about the project definition. It's important to spend some time into this and figure out whether it's a machine learning project or not. And if that's the case, then how are we going to design it? What is the scope? And so on. Think about the data, obviously, but the reason I mentioned this here is because of things like data sharing restrictions, which is a big thing in finance, especially if you are a global bank. Data quality is also extremely important because, well, it's garbage in and garbage out, so your models will only be able to be as good as the data that you're sending in. So you need to make sure that you know how dense your data features are, which means that how well populated things are. And sparse features here would mean that it's not actually populated, and sometimes that could be because of quality, but sometimes it's just how it's designed. And so you need to question those things and to make sure that the missing values in your data is because of design and not by quality. And by design, I mean it could be something that's just not updated on a regular basis. It could be something that's updated annually. And in that case, can you use it as a label? Can you use it as a feature? Those are the things that would be important to take into consideration. Even from the modeling constraints, think about the regulatory aspect of it. How auditable does your model need to be? Where is it actually going to be used? And if it's going to be something that will come into question that you need to be able to go and bring out the exact model at the exact time that built it, then make sure that everything you build is interpretable. From the evaluation aspect, I put that as an important aspect here, not from the model performance side, but from the actual communication from business to data scientists and so on. Here, evaluation is a measure of success, and that can vary based on what the business expects, which is generally dollar value, as well as what the team thinks about, which could be in terms of probability scores, it could be in terms of technical depth, robust design, scalable infrastructure, and so on. From the user interpretability, it's good to have data literacy in the team so that the users can actually understand what those models are doing. It's not their job to be going and researching how to make sure what your probability score means. It's our job to go and tell them that this is how you can interpret it. So the language needs to be translated correctly so that that can be utilized. The same goes for the model interpretability for a regulator. And also you want to build something that's reusable so that you don't have to do it again. You trust me, you don't want to go and spend hours and days and sometimes months in identifying certain features and then go do it all over again because nobody knew that someone had already worked on those features. So it's important to bring those things together and make your team aware of what's being worked on and what can be reused again. And at the end of the day, it's important to keep the overall vision in mind and make sure that you know what you're designing for, you know what your output is, you know where it's going to sit and what it's going to look like. And what it's going to look like should be something that's already been agreed by a relationship manager, by a GRB, that they know that this is how I can use these scores to then go and tell my clients and be able to use it. So let's delve a little bit deeper into those. So project definition. Like I said before, please spend a lot of time on this to make sure you clearly understand what the project is. And from that, I mean, both from the business goal and how that translates to the technical goal. It's very easy to think about certain things from a business aspect and not understand that actually when that's broken down technically, it's a lot of steps. And that means that one request can actually turn into 1,000 steps. And it's good to make sure that that sort of communication is managed. Also good to understand whether it's an automation or a prediction problem. How are you going to define success? Who is the end user? Are they involved in this process to make sure that their requirements are understood? What is the project scope? Is it global versus regional? Is it tactical or is it strategic? Very important from timelines and how much time that you should put in and resource you should put into building a scalable infrastructure. Because if it's a tactical one-off, maybe it's not the most practical thing to do. Identifying the scale of the project, that is how much data, how much resource would you need in terms of machines, your cluster, how big is it, can it support this project? Also going back to the regulatory and sharing restrictions, sometimes those can take months to be approved from a sharing perspective. So if the project scope is a month, but the data sharing restriction is not going to happen before 2 months, then that's something that you should probably think about before. Right, so the data and the data quality. Financial data is massive and actually, unfortunately, riddled with a lot of data issues. So the reason these crop up is because the data has been designed and stored in multiple legacy architectures and then redesigned, and that's how it's been evolved. So there's a lot of problems, especially when it comes to resolution, as I'm sure many of you are aware if you're in that industry. Amalgamating all of those resources, tracking all of that back to one user is very difficult and is generally not 100% accurate. So those are the things that you need to learn how to work around. They can easily take from a day to 6 months, depending on how complex that underlying design is for the databases. We easily have databases that have thousands and thousands of tables in there, and a lot of whose documentation is just lost. So it takes a lot of time to then go and understand, interpret what all of those things mean. It's good to then start instilling those data practices. Sometimes businesses actually change the whole team strategy to just invest into good data practices. For a global bank, that's not very practical. And while it should happen in parallel, it can't be the dependency for immediate projects. So the way to get around this is you do have to do the work that's involved from the data quality side, but try to do it only once. There's no point in forgetting about what one team did and then do that again and again and again. Instead, try to make sure that when you do invest time into going and getting all of those payments together, then you've done it because in a very scalable way, and you've done it because you don't want to do it again, which means that different teams can then go and access that. Obviously, with sharing approvals in place, they can access that, and it always has a layer of DQ, a layer of production monitoring around it. So build what we call as a feature store. There's multiple designs of what feature stores look like. We generally keep the features separate to the models because of, again, data sharing restrictions. In this design that I've mentioned here, which is also one of the good designs, is where you have all of those together. This then helps you make sure that the data going in has some sort of ingestion schedule in place, has a layer of DQ, has a layer of testing involved to make sure that's maintained. The data scientists can then easily just read from those feature stores and then also store their model within there. But yeah, this is very pertinent to what design works for your business with given all of the restrictions that we have in finance, but it's good to try to reduce your work and to make sure that everything is as maintained as possible so that you can reduce reduplication of code. Right. The data sharing and model constraints, there is a trade-off between interpretability as well as accuracy. So the more complex the models get, the more accurate they'll get, but also the less you can understand them. So the more black box they would get because of the higher dimensions, which means that you increase the number of data points that you use. So it's important to understand from an audit perspective what you need to be able to produce when you have to do that audit. It's also good to get the core team involved in this discussion so that they know that they are limited by these constraints. This can impact the overall model design. This can impact the amount of time it takes to get there. Sometimes it will also restrict the amount of data that you have because you might not actually have sharing approvals for all of it, which means that the data is now halved, and it could mean that that big data is not so big anymore. Evaluation. Definitely worth understanding what is the success definition, because your business expects a dollar value, the team expects good model results, and maybe the regulatory body expects interpretable results. So it's nice to have the discussion earlier and have some sort of ground rules that this is what we need to do, and also to bring in the end user as well, because their definition of success would be what they can actually use. From the team aspect and the business aspect, it's nice to have that already agreed upon before beginning the project. Data science literacy, I mentioned this earlier, and I think it's really important because it sort of brings everybody together and everyone can then contribute and feel involved rather than left out because they don't understand the black box version of it. So it's important to make sure that we invest in educating everybody in the team and to bring them together in the whole data science revolution. This also will then give them the power and it will empower them to then go and take those results and talk to the clients who would then want to invest into your product. From the regulator aspect, it's the similar reasoning. You need to make sure that all of your features, models, the reasons behind dropping features, the reasons behind deriving features, imputations, there's a lot of clever ways to impute that. Not a lot of that is interpretable. So if you have to answer to a regulator about why you imputed something, then you should make sure that those definitions are also something that you understand and you can reproduce them. It's also good to have some sort of bias correction if you're working with things, features that are things like gender, and even word embeddings can then be introduce implicit bias. So it's necessary to introduce those bias correction models as a layer in your workflow. The way to easily do this is to have an production ML flow workflow in place. I'll talk more about it with an example, but some of the things that we use are ML flow, which kind of tracks all of our experiments. It tracks all of the parameters and the data points that led to the results of that experiment. And we can pretty much go and compare our outputs and make sure that we pick the right model. But also from an audit perspective, we can go and also pick up what reasons were there that led to the production of this model. An example of what an interpretable layer can look like, and this is Lime, where you have your model, you have the certain features, and then it picks up the relevant features that led to that production. And so, the prediction. And so the interpreter can basically pick those features out and know exactly why this prediction came into place. So a good ML workflow, this is an example from GCP, and basically a good ML workflow is going to make sure that everything is scheduled correctly. Things are running only after the previous step has been completed. Your model that's being deployed is constantly monitored and the predictions are stored. You can also then go and ensure that you are able to go and pick up exactly the right version of the model that you used to get to this outcome. So this is an example of what the ML flow site looks like. So I've just run 5 different experiments here, and you can see what parameters I used. You can see the change in my metric scores that I have. And if I wanted to compare them, I can basically just put them against each other and compare the versions of my different models and then pick the one where I have the least error in this case. We also have the model artifacts and register. So this is where I go and store my model, and I can also store things like graphs. That should be the ROC graph of my model, or even just what the outcome is from a loss curve perspective. And I can go and pull those out as and when I need. They work in a SQL backend in your infrastructure, so can easily be integrated to any sort of modeling infrastructure that you have. And at the end, always make sure that you think about vision, because it's really important to take user engagement into consideration. A good model should be able to wow your users, especially in industry where machine learning hasn't reached that peak yet. And it's important to bring everyone together and to have a good UI experience. Whenever we pitch our model outputs, we generally get questions around, can we go and interact with this model? Can we go and pull up the graph? Can we go and look at the different communities that you have in a graph? So it's really nice to have that sort of UI experience. Apple is a great example for this. They have a huge amount of technology that goes to produce what they have, but really what wins everybody over is the UI experience. One of the books that I really like is Information is Beautiful. It's an old book, but it's very engaging. It shows how you can represent data in different ways, and it's good to invest in your team to make sure that they can also understand what good visualization would mean. Uh, and the last thing I'd want to say is that make sure that you think about reusability, especially even from the model aspect, the model output aspect. We're working on a new project in sustainability side, and it's great for us to be able to reuse previous models. So we can look at the features that we've already built. We can look at different trends that we've already built. And this enables us to reduce the amount of time it will take us from POC to proof of concept to production. And I think that's about it. I'm happy to take any questions if there are some.